G'day. I got sucked down a rabbit hole this week. One of the guys at work, and I've done some stuff on his plotter, which you'll see sooner or later, depending on how time flows through the tubiverse. Anyway, pen plotter, very old, can't get pens for it anymore. And so there's various hacks on the internet for how to resuscitate old pens and all that sort of thing. But I started off making up a couple of these for him. And these are just I guess a tube with a flange on it, and the flange then locates in the pen holder and you can use that for plotting. And that's all very nice. But then I started thinking about, well, how could you actually do something with ink? And so I was looking at one of these pens and thinking, well, there's quite a bit of ink in there. It's a gel roller pen. That should be all right. And so today's video is about making up one of these, which is basically that in metal without the retraction function. So the refill from here goes in here, and then that's held in the plotter, and off it goes. This is the start of the rabbit hole. This is a bit of 2011 aluminium. It's a free machining grade, and you can tell that because of the chips. The chips are very short, compact, so great for a chip conveyor. The other thing that Capral stock is 6061 or something like that, and that gets a lot longer sort of chip. So the downside of this stuff is that it doesn't weld as nicely. So if you're just doing machining, then 2011 is fine. If you want to weld, then you've got to go for a 6000 or a 5000 grade, but that's just beside the by anyway. So this one, this is the start, and this is designed to have a pen go through the middle. And all I've done is I turned it down to the OD, left a flange on there and put a bit of a bevel on it. The original part is injection molded plastic, and it's got draft on it, so you need that bevel because the part that it mates in is designed to have that draft on there, so that helps center everything. What I now need to do is put a hole down the middle and then just part that off. The distance between the lower flange and the end of the pen is critical. It's 28 millimeters, and so what I usually do is I look on the pen, see whether there's a step, and then part this out off to suit so that once it's in place, that is in the right spot. There's that one. That's pretty straightforward. I drilled a hole through the middle and half a millimeter under my final size, and then I used a final size drill to take that out to size. With some of them you may have to get something like an adjustable reamer in there and just nibble them out just a little bit. I made one of these for a Sharpie, which was 10.65 I think it had to be, so I drilled it out to 10.5, and then I had to just take a little bit out with the reamer, but that gave me the size I needed. So that's all good, and that sits in the which side is that way? That sits in the pen holder, off it goes, does its thing. However, I then thought, well, that's fine for an existing pen, but what about the refill from a pen? You know, a little bit more compact, a little bit easier perhaps to do. So what I did was I sat down and measured one of these up and came up with a drawing. Now, that's the detail there, and one of the key things for locating vertically is that step there. And so what I've done is I've gone and drilled this hole and this hole. I've left that one for the moment, and then I've gone and put this one in. Firstly with a normal drill, and then I'd come in with one of my flat bottom drills to put that step in. And that step's critical. Now that I've got that there, I'm going to go back and place this step here, because the relationship between there and there is extremely important. Okay, once I've done that, I can then take the rest of this down to its major diameter, flip it round and do this outside detail as well as doing this end diameter here. And that one is critical because it stops the pen wiggling from side to side. So I want to do that with as short a drill as I can. But other than that, that's clearance, so it's really, this is controlling vertical position and that's controlling horizontal position. A bit further along now, because I've got that flat bottom hole in there, I can work out where this was, and that took a little bit of trial and error. I had to measure the distance of that step, and then I had to wind the the compound in a little bit to do that. To get my flange width, I just said 3mm wide cutter plus a 2mm flange, 5mm, wind it in 196 millimeters. That got that, and then I can just step along as per normal to get that to size. Before I take this out though, what I need to do is put a thread in there so that I can screw a retaining piece onto there. I'm not sure whether I should do an inside or an outside thread. I need to have a look at what taps and dies I've got. I also need to be able to pick up on that flange, so it's probably going to be an internal thread, possibly something like an 8mm or whatever, but depends on what fine pitches I've got. I don't want a particularly coarse one because that's going to give me a deep thread which will lessen the strength of that. I'm turning a piece of this down to 11.6. If I had some smaller stuff I'd use that, I haven't, and as I said, this stuff isn't too good for welding, so I'm quite happy to use this up in lieu of anything else. What I wanted to show you here though was a way I get round small diameters into my centre. The right, or is it left, I can never remember which way it is, tool, if I put that in there, clashes with the centre. So what I do is I come in with a parting tool and just plunge into my finished diameter, or very, very close to my finished diameter, and then I can take this tool out and put that tool in, and I've now got enough clearance that I can get in there and do my cut. Now obviously to match those two diameters I'm going to have to be careful, but that's one way of getting around the problem of, you know, clash with the center before you're at the start of the bar you're turning. I've realised I've forgotten a bit of explanation here. The reason I stopped working on this bit and went on to this bit was that I've now put a 3/8 20 thread in there. It's actually a BSF, British Standard Fine, and while I could clamp that in my 3-jaw to put the outside on there, which is basically cosmetic, so concentricity isn't such an issue to me, I would prefer not to crush the thread. And so what I'm doing is I'm turning up the piece that's going to screw into the end here, and I'll put that in there, and that'll just give me a little bit of extra material, shall we say, to you know, clamp on and have a slightly more rigid assembly, I guess, for while I'm machining. Now, I've used the same technique I used to reduce the diameter down here to put my starting diameter for the thread. So I'll now put the die in, my die holder, and just run that up. I'll then have to put a relief groove there so that the thread doesn't just end. It's got the other part can screw up onto it. I'm able to run my, what would you call that, nib end or something like that, almost right up to my diameter here, and that was I cut the thread here first with one side of the die, and then I flipped over. What you'll notice on some of these dies, not necessarily all of them, but one side has got a better lead in than the other. So you start with that one, but if you need to run the thread up to a shoulder like this, then you can flip it over and use the other side to just cut that little bit more. Now here I've got a gap which is roughly 1.9 millimeters, so I can come in with a parting tool and just take that out, those half-formed threads out, and I should be able to thread that all the way up to the shoulder there. That's my assembly there. As you can see, I've only got a few threads there, but that's all I need. I've got the relief groove there to cope with the threads on the start. I guess the other way I could have done that was counterboard that a little bit so that it would accommodate the imperfect threads, but this way works just as well, maybe a little bit better, but that does up nicely. So I need to drill that out to the right size, and I need to shape the ends of this. I'm going to start by shaping the end of this and then worry about drilling that out. Here's my tip. The material off here is pretty much arbitrary. I've just shaped this so that I've just taken a bit of mass off. These plotters don't deal with heavy weights, and so the lighter you can make it, the better. But that's basically the finished part. I'll just take that out of there like that, and if I unscrew that like so, what should happen is my pen should go in there. I need to deburr some holes there, but there's my pen. If I get my rule, that should be 28. It's 27 at the moment, so I might have to deepen a hole a little bit in there just to get that to be the right distance. I'm drilling my hole in here. I started out with a normal 1/4 inch drill bit because the ink tube is 6 millimeter, and so that's I've got gives me a little bit of clearance. And then I've gone and switched to a long series drill, and I'm pleased to be able to say that you can buy these. Well, I bought this one in a mitre 10, I believe. So some of the local hardware shops do stock a longer series drill bit, which is handy for these sorts of things. The normal one runs out of fluted around about 50 odd millimeters. This one's got a little bit extra, which will just get me through, I think. The problem with drilling deep holes is that the chips don't always evacuate nicely. So what I find is you drill for maybe 15 millimeters or so, 20 millimeters, and then you want to withdraw the drill, knock the chips off, squirt a bit more lubricant in there perhaps, and go again. So what I'm going to do now is get my tip and get my pen and work out how much more I need to drill. And according to that, I need roughly another 35 millimeters. So I'll do another, we'll say inch, and then we'll remeasure. Here I confess to screwing up a little bit. After drilling that out and think, oh good, that's about right, I parted that off and put a bit of a chamfer on there. And then I went to try the pen in there. And, it went in there all right, except that you might just be able to see there's a little bit of movement there. I've drilled that hole too deep. Now, a couple of ways you could fix that. One of them is drilling that out and putting something like a grub screw in there with a lock nut. And that would be nice if you wanted to get some adjustment on how these things were going to go. But what I've come up with is this. This is a little bit of brass, 1/4 inch. I've put a 120 degree angle on there, so it mimics basically what the drill has done down the bottom there. But that's just the right thickness that brings that pen refill to be fixed, and so that's all I need to do. So what I'm going to do is put a bit of Loctite on that and drop that in there. The other thing I want to do with this is put a couple of slots in the side so you can see what the ink level's like. I mean that'll lighten this up anyway, but it also means that yes, there's a bit of feedback as to what the ink's doing in there. Anyway, that's the pen. Never thought I'd be doing pen making. Thanks for watching. See you for the next one.